Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. Day 14, Regolith Reservoir. The distress signal leads you to a giant waterfall. Actually, hang on! The signal seems to like it's coming from behind the waterfall itself. That doesn't make any sense. However, you notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind the giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment and sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you will quickly become trapped. Unfortunately, your familiarity with analyzing the path of falling material will come handy here. You can scan a two-dimensional vertical slice of the cave below and your puzzle input and discover what is the most air with a structure made of rock. Your scan traces the path for each solid rock structure and reports the x-y coordinates that form the shape of the path, where x represents distance to the right and y represents the distance down. Each path appears as a single line of text in your scan after the first point of each path. Each point indicates the end of a straight horizontal vertical line to be drawn from the previous point. For example, this scan means that there are two paths of rock. The first path consists of two straight lines, and the second path consists of three straight lines. Significantly, the first path consists of a line of rock from 498.4 to 498.6, and another line from 496 through 498 to 496. The sand pouring into the cave from point 500, drawing rock as hash mark and air as dots, and the source of the sand as a plus. This becomes like this. The sand is poured one unit at a time, and the next unit of sand is not produced until the previous unit's sand comes to rest. A unit of sand is large enough to fill a tile of air in your scan. A unit of sand falls down one step if possible, if the tile immediately below is blocked by sand or rock or sand. The unit of sand attempts instead to move diagonally one step down and to the left, and if that tile is blocked, the unit of sand attempts to instead move diagonally one step down and to the right. Sand keeps moving as long as it's able to do so, and each step trying to move down and then down left, then down right. If all three possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the unit of sand is created back at the source. So drawing sand that becomes to rest as an O, the first unit of sand simply falls down and then stops. And then they draw it out here and shows how it fills up. And then they come to, once all units of sand above, of 24 units of sand above come to rest, all further sand flows to the bottom, falling out to the endless void. Just for fun, the path of new sand takes before falling forever is shown here with the forever sign, okay? Using your scan simulating falling sand, how many units of sand come to rest before sand flowing into the abyss below? So first off, let's go for line split by that sign. chords. Like that. And for chord in chords. Min x let's do 2000 min y int max x max y. So let's do that first off. So we take this chord and split that with and here we want to do a trim, and we do the same for this split, like that. Then we should have some value here, and then val 0 min x should be equal to math min of min x and the integer parse int of this value. So let's give us a little bit more space here. I always forget that. So then we'll do the same for x here, or y. And then we want to do the same for max x and max y, and change these to max. And if we do min x plus max x, like that, we can do the same for y. Then we know how large of a play area we have. If we run the right day, of course. So let's run day 14. So here we have a pretty small area. And if we go for the much larger one, what do we have to play with then? Well, it's not that much larger. So we should be able to have a play area here of, so this is less than 100. So if we start at 450, we should be able to take 150 in x. So if we say here max y x is 150, let's say 200, and 200 for that one. So if we start at 400, we can go up to 600. If we start at yeah, so just a play area of map max x times max y. So that is our play area, but the chords needs to be subtracted with 400. So now we can do draw. Now we have a bunch of chords. So 4 int I to I smaller than chords length -1 I++. So now we should be able to draw chord chords 0 to chords 1 like that. So let's see here. Don't have to remove all this. Yeah, it doesn't really matter. Like that. From 2. So now we want to take from and trim split on that. We have 2 strings. And then we have 2 strings here. And then we want to have from x is equal to that value, parse int. Two here. And now we need y as well. If from x is equal to 2x, then we do one thing, else we do another thing. So in this case, we want to loop where I is equal to 2 from y I less than 2 y plus 1 I plus plus. And then we want to take our map, which I realize need to be a private static map, like that. And these can also be private static. We have those. Part up here. So here we can take from x minus 200. Map is I times max x plus that. So here we want to set rock. And then down here we do the same, but for x. So here we want to take from y, for instance, to from y, and then we do this I here, minus 200. So that should draw a map for us. Shall we paint the map? Draw map. Then we have these x 0 to x max x x. Do the same for y. Max y. So here we want to do y times that plus x, and system out print, and if that is equal to 1, we want to draw an hash mark, else we draw a dot. And then we do a system out here. Print line, so new line. So if we run this program, we should have a large map here. And at the top we have math min of those two, math min of those two, and then we do the same for the two values, but we do max instead. Draw in both directions. Let's try that out. That seems like what we're looking for. So we can draw this shape. So then we can move sand. And we can do that while it's not resting. So while it's not resting, we can move sand. So at rest, as long as that is not true, we can move it. So that is what we do there. And while true, up here, we do something else. And here we will take if x, or if x is larger than 0 and x is less than 200, and y is larger than 0 and y is less than 200. Then we do one thing, else we break. And then we will need to have a sand count. And here we take the sand count and add to that. And down here we want to sand count and print that out. So that's the amount of sand we pour down. And if we have moved the sand and it is at rest, we want to draw it out here. So we take the map and take y times max x plus x. And that should be a 1, 2. So then we have a rock there again. We could say 2 and then add to this one if this is equal to 1, then else if this is equal to 2, else, oh, we don't do the last else, string, draw, and then we do that, we put in draw down here, and in each of these we have either a sand block or an O. So we draw it out as they did. So now we need to move sand. If x, the map, max y, max x, so y times max x plus x, so that is where we are currently, equal to 0. So what we want to do now, we want to go 1 down. So if that is true, then we will say that y is increased. Maybe we don't need the actual function. I don't think this will become that complex. So here we are not at rest. And if y plus 1, then plus 1 down here, we do another plus 1. Yeah, we first go to the left, else we do that, we go to the left, else we go to the right, like that. Else we are at rest. So at rest is equal to true. So let's see what's happening here then. As long as this is true as well. So we can actually go forward. So let's try that. Yeah, so we get 24. So if we now switch over to the full example here, and let's go back here so we don't get that extra complication. No. What are you doing? There we go. Let's try that. 979. Could that be the right answer? Let's try that out. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So we solved the first one. You realize that you missed the scan misread the scan. There isn't an endless void at the bottom of the scan. There is a floor. You are standing on it. You don't have time to scan the floor, so you assume the floor is an infinite horizontal line with an x coordinate equal to 2 plus the highest y coordinate. In this example above, the highest y coordinate of at any point is 9 and the floor is at 11. This is as if you've scan contained an extra rock path like Infinity 11, which has added the floor. The example above looks like this. To find somewhere safe to stand, you need to simulate the falling sand until the unit of sand becomes to rest at 500, blocking the source entirely and stopping the flow of sand to the cave. In this example above, the situation finally looks something like this after 93 units of sand comes to rest. Using your scan, simulate the falling sand until the source of the sand becomes blocked. How many units of sand come to rest? Okay. So we actually looked at this before, but we threw that code away. So that was a little bit unfortunate. But I think that we could do like this. Private static int find max y. So we do like that, and it starts at 0. And then when we draw chords, we can take the 2 value. Find max y is equal to math max of this to y. And then down here we can take, or even when we are figuring this out, so here we can take find max y and print that out. If we run this, we should have 2 values, so 174. So 176 should be the infinite floor then. So in order to draw the infinite floor, we do draw chord 0 for x 176 2 and then we do 200 176. All right, so that is for the full example. And for the smaller example, we run the find again, and it says 9. They say the highest value coordinate at any point is 9, so 11 should be there. Yeah. So let's do the same here, but for 11. Offset x. And let's go up here and then say private static int offset x should be 200. Offset x plus max x should be the value there, and then offset x should be the value here. And we can take this minus 1 in order to not overdraw it. What do we get then? We get 10,000. We get to the edge there. We don't do there. Then where we actually are placing this needs to be 500 minus offset x. We do. This is exciting. So the offset should be 200. And then we get that value plus 1 because we didn't draw the last stone. So 29,044. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So the problem here was to figure out how large of a drawing area we need, how much of an offset we needed to say, because we don't want to have start at 0 if we actually have a starting point of 500. And then we needed to update all the values. We need to update where the sand falls. We need to update where all the blocks are drawn. We need to update everything in order to figure out where we should put the floor and how we should change our play area up. So there was a bunch of different things that we needed to figure out in this model, but we came to a pretty good solution where I actually understand what's going on. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any code that you want to share with me so I can see how you solve this solution, solve this problem, or if you have any other comments or suggestions, leave them down in the comment section down below. And I really hope to see you in the next video.